Hello friends, welcome to Susan and John MathTube. In this video, we are going to continue our discussion based on Fourier series. And this will be the last video in Fourier series. And here we discuss about the half-range Fourier series. And before we start, you have to understand this Fourier series will be based on functions defined in the interval 0 to L. Okay, so our function will start at 0 and let's say it ends somewhere here L. And let's assume this is our function, some graph, some f of x. So we have a function which is defined in 0 to L, and this is the graph of the function. Now look at this. What we do is we duplicate this function to the negative side, that is from 0 to minus L we are going to duplicate it. And I have two options. One is I'll duplicate in such a way that f of minus x will be equal to f of x. That means when you input any negative number, you're going to get the same output which is in the positive side. So for example, the height here is this much, so my graph will get the same height but in the opposite direction. And this is an even extension. What do you call this? An even extension of the graph in the interval minus L to L. So even though our function is defined only in 0 to L, what I did is I extended the function so that it is defined from minus L to L. That is, my new function is defined from minus L to L, and my new function is an even function. And in the earlier videos, you have seen that if you have an even function defined in minus L to L, then Bn will be equal to 0 and only A0 and An, that is the Ans, will exist. Now what we are going to do is, let's again start with a function which is defined in 0 L as before, and let's say this is our graph. Let's say it looks like this. Okay, now what I'm planning to do is I'm going to make an odd extension. So this is our origin, and let's say this is L, and I'm going to the negative side minus L. Odd extension means f of minus x will be exactly the negative height of what you see on the left side, on the right side. That is, you can see that the height is this much. So at the same point in the negative side, the depth will be this. So basically the graph will look like this. So we have an odd extension. What do you call this? Odd extension. That is, our extended function f of x is defined from minus L to L, and it is an odd function, and that implies A0 and An will be both 0 and only Bn will exist, and Bn will be given by 2 by L, etc., etc. You can check the formula from the previous videos. Okay, now I'll make it more clear. So let's say a function is defined in the interval 0 to L, and let's say we want a sine series. So what do you want to construct? You want to construct a sine series, and you know very well Bn is the coefficient associated with sine. So you want Bn to exist, or you want Bn's to be not equal to 0, and you want both An and A0 to be identically 0. Or in other words, this can be attained by giving an odd extension. So all you have to do is you have to give an odd extension. And finally what happens is our function will be equal to A0 will be 0, An will be 0, so the summation will be n equal to 1 to infinity Bn sine n pi x by L. You can note the formula where Bn is given by 2 by L integral 0 to L f of x into sine n pi x by L. Now, similarly, suppose you want an expansion in which you want only cosine terms, that is, you don't want Bn to exist. So all you have to do is you have to create an extension from minus L to L so that the given function will become even. And if the given function becomes even, you know that Bn will not exist and a0 will be given by 2 by L integral 0 to L f of x dx, and an will be given by 2 by L integral 0 to L f of x into cos n pi x by L dx, and the function will be given by a0 by 2 plus sigma an cos n pi x by L plus 0, where n varies from 1 to infinity. So this is called the half range cosine expansion, and this is called the half range sine expansion. Okay, now we'll do one thing. Let's do some numericals and make the concepts clear. And you can find the notes down here. You can just scroll down and download if you want the notes, the formula, etc. I'm going to upload the notes together with this video. Okay, and if you're watching this in YouTube and if you want the note, just visit our website, that is www.sjmathtube.com, and you can find it in the third semester videos of IUE engineering syllabus. Okay, so let's start. So please note the question. I hope you're ready with a pen and a paper. So the question is, obtain the half range cosine series. So look at this. It will be clearly mentioned in the question whether you want cosine series or sine series. So obtain the half range cosine series for the function f of x is equal to x in the interval 0 less than or equal to x less than or equal to pi. Okay, now one very important thing. In the previous videos, I told you the length of the interval is 2L. But remember, the function which we are going to expand is not this. The function which I am going to expand is the extended version. And even though the given interval is from 0 to pi, once we extend, it will be from minus pi to pi. Or in other words, 2L will be equal to 2 pi. And that means L will be equal to pi. Or in half range series, you always remember L will be the length of the given interval. I'll repeat once more. This is a shortcut. In half range series, you always remember L will be equal to the length of the given interval. Is that clear? So L is settled. Okay, now let's look at this. We want the cosine series. So what do you want? We want the cosine series. And the cosine series means Bn will be equal to 0. That means we extend the function in such a way that our function will be even. Okay, you don't have to remember these things. All you have to write is, let the given function be expanded in the form a0 by 2 plus sigma n equal to 1 to infinity an cos n pi x by L. But we already found that L is equal to pi. So this pi and pi will get cancelled. That is, our function means it is x is equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx. And you can call it equation number 1. A naught is given by 2 by L. 2 by L means it is 2 by pi, and integral 0 to L f of x dx. But f of x is x, so I reduced all the steps. So A naught equal to 2 by L, but L is equal to pi. So it's 2 by pi integral 0 to pi x dx. And I'm sure you know how to integrate. A naught equal to 2 by pi and then x square by 2 within the limits 0 to pi. So this 2 and 2 will get cancelled. So I get 1 by pi and put upper limit minus lower limit. And that is going to give me pi. So note it, A naught equal to pi. So as usual, let's put it in a box and call it equation number 2. Okay, now let's go for AN. So as before, 2 by pi, because it's 2 by L, integral 0 to L, f of x, that is x, into, so what's the function? Yeah, cos n pi x by L, that gives me cos nx dx. And we can use the shortcut because it's polynomial into cosine, and I hope you're comfortable with those things now. So 2 by pi, I'll put a big bracket. So x, and then integral of cos is sine nx by n within the limits 0 to pi, minus in the next bracket the derivative of x is 1 and integral of sine is within 0 to pi, and we get 2 by pi. So we have to clean this up first. So 1 by n x, never skip this step. I'm sure some of you can guess the answer without doing this step, but it's a warning. I have seen so many answer sheets where students make mistake at this point. So please be very careful and don't skip this step. Okay, that's it. So 2 by pi. And what's the value of sine n pi? That is 0. And what about cos n pi? That will be equal to minus 1 to the power n. And cos 0 is 1 and sine 0 is equal to 0. So when you plug in the upper value and the lower value, the whole thing will get cancelled. So let's forget about this. So 0 plus 1 by n square into, now we can put the upper limit. So we get cos n pi, and that is minus 1 the whole power n, minus cos 0, that is 1, and that will be our an. So that is 2 by, let's check it, pi and n square, pi n square, and the quantity in the bracket, minus 1 the whole power n minus 1. So I have all these things here, equation 1, 2 and 3, so that you can see all the equations. So our final answer will be x is equal to a naught, that is pi by 2 plus sigma n equal to 1 to infinity an, what is our an? Yeah, equation number 3, pi n square minus 1 the whole power n minus 1 cos nx. If you want, you can write the expanded version. So that will be pi by 2. This is not compulsory. In case there are some prove that or etc., you can use this. So when I plug in n equal to 1, you're going to get minus 2, because minus 1 the whole power 1 will be minus 1, and minus 1 will be minus 2, and 2 into 2 will be 4. So we are going to get minus 4 by pi, because this will be 1 square and cos 1x. Now when I plug in n equal to 2, this quantity is going to vanish, because minus 1 the whole square will be 1, and 1 minus 1 is equal to 0, and 0 into something will be 0. So the next term just disappeared. And the third term, when I put n equal to 3, the same thing repeats. So we get minus 4 by pi, but this time it will be 3 square. And I'll copy 3 square and cos 3x. And again it will be 0, and again it will be 4 by pi, and the next time it will be 5 square and cos 5x, etc., etc., etc. That is, x is equal to pi by 2 minus, if you want you can take 4 by pi common, and cos x plus cos 3x by 3 square plus cos 5x by 5 square plus etc. So that's it. So that's a half range series for x. Not only half range, it will be completely in terms of x. And we will use the range from 0 to L, because the 0 to pi, because the other part was created by us so that we can construct the series. Let's do one more question and make things perfect. And this time I want to work out along with me. So the second question, please note the question. Find the half range Fourier sine series. So I told you it will be clearly mentioned in the question. So find the half range, so it's mentioned half range. And is it sine or cosine? Okay, it's mentioned sine. Now the function. So the function is given by e to the power 2x, and the interval is 0 less than x less than pi. So let's start as usual. So the logic behind this is we extend the function so that it will be defined from minus pi to plus pi. And since we want sine function, we are not interested in a0 and an, so we need an odd extension. So whatever the graph which appears on this side, the odd extension will appear on this side. So this is the logic behind the scene. Anyway, if you are not interested in the logic part, I'll give you the shortcut. First thing, it is half range. So L will be the length of the given interval, not 2L but L. I'll repeat, half range. So L will be the length of the given interval. So L is equal to pi. Okay, next thing you have to notice is, okay, we need sine series. That means we don't need a0, an, only bn. So you write, let the function be sigma n equal to 1 to infinity bn sine n pi x by L. Now you substitute all these things. F of x is e power 2x, and sigma bn sine L is pi. So this will get cancelled and you'll get nx and call it equation number 1. Okay. Now let's write bn. It's 2 by L. In half range, it is always 2 by L. Integral 0 to L f of x sine n pi x by L dx. Now let's substitute the value of pi and f of x. So you get 2 by pi integral 0 to pi f of x is e to the power 2x and sine nx dx. In the previous video I told you, in your university exams they normally ask 3 types. One is polynomial, and the second one is sine and cosine related, and the third one is exponential. In polynomial we always go for Bernoulli's rule, and in sine we manipulate using trigonometric formulae, and in exponential we will be using the formula directly. I hope you remember this, and if you are not aware of these things, please watch the last video. Okay, so we have integral e to the power ax into sine bx format. And I gave you a shortcut. It is e to the power ax. Look at this, a and b. So divided by a square plus b square. And in bracket, it will be a sine bx minus b cos bx. Of course, plus c. So let's apply the formula over here. So 2 by pi and in bracket e to the power 2x by 2 square plus n square, and the remaining part will be 2 sine nx minus n cos nx within the limit 0 to pi. Okay, now let's put upper limit and lower limit. So I'm going to get 2 by pi, and I can take this outside because there is no x in it. So 4 plus n square, and now inside the bracket. So e to the power 2 pi and sine n pi is 0, we just discussed. So that's 0 minus n into minus 1 the whole power n minus e to the power 0. Sine 0 is 0 minus cos 0 is 1. So we get 2 by pi into 4 plus n square, and we simplify this. So we get n minus on the whole power n into e to the power 2 pi, and one more n remains here. Okay, now let's take n common. So an will be 2n by pi into 4 plus n square. Isn't it common? N is common, and the remaining part is 1 minus 1 to the power n into e to the power 2 pi. Okay, so this equation number 3, and that's it. So let's write bn. So bn is equal to, you can see n is common here. So 2 by pi into 4 plus n square, and n comes common, and the remaining part is 1 minus on the whole power n e to the power 2 pi. Okay, now let's substitute, and that's the end. So just put this in equation 1. Our function, that is e to the power 2x, is equal to sigma n equal to 1 to infinity bn. That will be 2n 1 minus on the whole power n e to the power 2 pi, the whole divided by pi into 4 plus n square into sine nx, and that's it. That's the end. So as always, thanks for watching, and if you find the video useful, then like, share and subscribe. And if you are watching this video from YouTube, don't forget, visit our website www.sjmathtube.com, and you can find the notes for this particular topic just beneath the video. You can scroll a little bit above and there will be a download button, so you can download the notes for the video you just watched. So I'll be back with more videos. So till then, bye.